Greetings. I am Professor Logic, here to explain everything. Rationally. Nah, I'm Captain Jokes, and I think logic is boring. Silence, mortals. I am the Dungeon Master, and your fate awaits.
Hi, I'm your overly enthusiastic life coach. Let's crush today.
Ugh, and I'm the teenager who didn't even want to be here.
Yes, so I have actually built multiple talking characters inside Alexa. This isn't just Alexa reading script. Each character has its own personality, powered by AI prompts spoken in a custom voice, and Alexa can switch voices dynamically based on the character I want. If you'd like me to build you something with AI, or help out with any project, I am a software engineer with a decade of experience, so feel free to reach out. With this in mind, so how does this actually work? When I talk to Alexa, the request goes to something called AWS Lambda function. Lambda is what's known as a serverless computing, which basically means I don't have to run or manage any service. I just upload my code and Amazon runs it whenever Alexa needs it. Inside that Lambda function, I send Alexa request to OpenAI with a character-specific prompt. The AI responds in personality I've defined. This is then sent to Resemble AI for a voice transformation and it's stored as an MP3. Then Alexa will play this MP3 so each character doesn't just think differently, they also sound completely different. So that's the big idea. Now let me show you how I build each character. Each character starts with a simple AI prompt. For example, here is one. The wise professor character with a calm, deliberate and articulated tone. The delivery should sound rational and precise, as if lecturing a classroom. Add a touch of humor by making it sound overly serious about simple things.
Tell me something interesting.
Have you ever pondered the vastness of the universe? It's astonishing how many galaxies exist, each with billions of stars.
A playful pirate character with a laugh, exaggerated emphasis. The delivery should sound funny and over the top, like a cartoonish sea captain telling a joke. Keep the pacing lively and add a cheeky attitude.
Tell me a joke.
Why did the server go down? Because it couldn't handle the treasure of requests.
So the personality comes from a prompt, and the voice comes from the Resemble API. Together that makes each character feel quite unique.
Tell me something scary.
Step into the darkness, if you dare. Your soul will not escape my dungeon.
Tell me something motivational.
You've got this today is your victory lap. Come on, let's turn that energy.
Tell your mom that you're sorry.
Do I really have to say this? Whatever this is, so not a big deal.
The best part is I can add as many characters as I want. Each one just needs a different prompt and a different voice settings. Now, of course, it wasn't that easy. Sometimes the AI responses would take so long to respond that the Alexa just gave up. Alexa has an 8-second timeout, so if the answer isn't back by then, the whole interaction will fail. That means I had to carefully balance the response size and speed. For example, if I let the AI generate a large response, it could take 2-3 extra seconds than just small to medium one. And those extra seconds really matter for a more natural conversation. So I usually has capped the responses at around 200 tokens to keep the responses quick. I also had to choose the right AI model. If I used the reasoning heavy model, the responses were way too slow. So instead, I picked a faster model, one that prioritized speed over deep thinking. Because in the conversations like this, natural flow is more important than perfect reasoning. So it's now working pretty well. Let me show you a live demo.
Open custom characters.
Hello, I'm a random character. Do you wonder who will you hear today?
Tell me something interesting.
Welcome, class. Today we will discuss why pirates are terrible at math.
Because we always get lost at sea.
That was the best pirate joke I've ever heard. High five, everyone.
Seriously? That was so cringe.
And that's the magic. Alexa isn't just reading lines. Each character has its own personality and its own voice, all powered by AI prompt and dynamic voice switching. This is just one example, but I can imagine using it for games, storytelling, or even interactive education. So what did I learn from all this? First, Alexa is way more flexible than most people think. By combining AWS Lambda with AI prompts and voice switching, You can give it personalities it was never designed to have. And this isn't just for fun. Imagine customer support where Alexa can switch between friendly assistant and a technical expert, or maybe an employee training where a different character guides you through different scenarios. Even marketing where a brand could have multiple voices representing different styles. Of course, speed is critical. To make conversations feel natural, you have to prioritize fast models, shorter responses, and a smart limit on tokens. Otherwise, the responses will be slow and Alexa might get stuck. And beyond business, this opens up a ton of creative possibilities. Interactive bedtime stories, role-playing games, or even teaching history by letting you talk to historical figures. If you're curious how to build this yourself, here are the approximate steps. So first, you're going to have to create an account on AWS Amazon.com, and then you're going to have to select your region based on where you are. Mine is US East 1, but you can select the one that is the closest to you. Next, in the search, type in Lambda. A Lambda is an AWS service that allows you to execute code without running server, so the code only runs when it's requested, which is perfect for what we're trying to do. Next, you're going to have to create an account on developer.amazon.com, and if you use the same email address that you use with your Alexa devices, you'd be able to test your skills inside the dev mode. So that means you won't need to go through the extra process to getting them ready for production. My skill is already created, so let me just show a couple of things that you need to be aware of. Once creating new skill, there is this invocation skill name, and that's the name that you're going to give it to your skill. So when you say Alexa open followed by this invocation name, it will open the skill. Next, we want to take a look at interaction model intent, chat intent. It's a custom intent I have created to specify the interaction model with my custom skill. So here we have the list of queries that I need to use in order to interact with my skill. And anything outside of that list, the skill won't be able to understand. Inside the endpoint, we need to specify the location of our Lambda function. So this is the place that we're going to deploy our code into, and the Alexa skill will be able to get the data from. So each time the skill is being invoked, it will use one of the intent invocation model, and the data from that invocation will be sent to this Lambda endpoint for processing. Finally, inside the languages, as you can see, my primary language is United States, but we can make the code available across those secondary languages as well. So that means we don't have to deploy it several times, but the copy will be available for those. So next, I'm going to show you the Lambda code. I'm not going to go into massive level of details. I'm just going to show you roughly what's going on. So here at the top, we have defined the environment variables. So those will be passed as arguments to the Lambda function, so they can be changed and experimented with without redeploying the whole function. So here I'm going to be passing the Resemble API key, the voice UID, OpenAPI key, the AI model to use to create responses, and the size of the output. Each Lambda function has a single method called handle request. Once the request comes in, that's the initial response I'm going to get. And any other request, it's going to go through the chat intent request, which I have showed you in the Alexa developer console. And then we're going to grab its value, and then we're going to call OpenAI with it. Inside OpenAI, we're creating the system prompt. As you can see, the prompt is parameterized based on the character that we require. We're then using the HTTP request to call the OpenAI endpoint. We're passing the OpenAI key and the request body, which is this whole message that contains the prompt. We send the request, print the response, and then this response is then being returned. So once the response is returned, we're sending the results to another API, which will change the voice. We specify the voice UID. The user input is the response from the OpenAI. This is then being sent to the API. Once received, we extracting the audio content as a JSON, and we store that in AWS S3 bucket as an MP3. Finally, we return that value as an MP3 for Alexa to speak. So as you can see, within this speak parameters here, we're passing the audio source, which is the location from S3 bucket where we have uploaded the audio file from the Resemble API. In here we have a simple character prompt that we can switch between based on what character we want to return. So this represents all the 5 characters that you have seen in the video. So once the code is ready, we can go back to the AWS console, go to the Lambda service, create a new function and upload code, or if you have an existing function, go into it. In here we can upload the zip or jar file that contains the code. Once you hit save, that will update the function automatically. Then we can also test, give the event name and pass the JSON that will mimic the Alexa interaction, and that way you'd be able to verify if your Lambda function is working as expected. Once happy with your logic, you can go to the versions, publish a new version with the uploaded code, and then you can create an alias that will allow you to create deployable version of this code and specify the code version against that alias. With this in place, you can use the location of this Lambda function, which is then being passed to the endpoint inside the Alexa developer console endpoint. And here we can see that this matches the location right here. So you copy that and paste. And then if you want to deploy this for other regions, you will need to select an appropriate region in your AWS console, create a copy of that Lambda, and paste the endpoint here. And it's going to be a bit different because the location is part of the path. With this in place, you should be able to test your skill inside the console.
Hello, I'm a random character. Do you wonder who will you hear today?
So as long as you've seen the initial interaction, that means the skill is ready. And if you have used the same Alexa email for registration on the developer Amazon console, that skill will be available on your Alexa devices as well. So there you have it. I've built multiple talking characters inside Alexa, one with its own personality and voice, powered by AI and AWS Lambda, from professors to pirates, life coaches, to even sarcastic teens. Alexa can now be whatever you want it to be.